Okay, half of the class right now. Okay, Assalamualaikum and good morning to everybody. All right, we just started our chapter 5 this week, stiffness metric method. So we're gonna have truss, beam, and frame. So for the first part, we're going to start with truss first. So for this truss, there will be question from this part, truss and plus cable. Okay, hopefully you downloaded those material in Kalam and don't just go for my video, because my video explain this note. All right, now after the group discussion I asked you to do, there is the question. Take this as an example. Initially, your truss without load, and when you apply a load at this point, you're gonna have a deflected shape. So this will be your deflected shape. When you increasing this force gradually until you get this shape, you're gonna have tension and also compression in those member. All right, for this question, at each node, so how many nodes we have? So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 nodes for this truss. And at this node, we have X and Y axis for displacement. So this is your X, this is your Y global direction. Okay, so this is your deflected shape when you slowly or gradually increasing load at node 4. All right, clear for that? So you have 8 nodes, and how many member you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 members for this truss. Okay, next. Due to this external load, all nodes going to have displacement from its original position. So this is original position. So due to this load, you're gonna have displacement at node 2, 3, 4, 5, 6, and 7. So this node going to have displacement. So this node respectively. However, nodes 1 and 8, because this is support, displacement for that is 0, dk 0. So dk is d known, which is from the support, you know the condition of that, there will be no displacement, which means dk is 0. For du, so du, d for d unknown. So dk, d known. D known, check your support. So if that support pin, you know there is no displacement on X and Y. And for roller, one of the axis will have displacement. So when is 0? Dk is 0. Okay, clear for that? Hopefully it's clear. All right. Then I ask you to do this exercise. For this truss, you have pin and you have roller, and subjected to 5 kilonewton horizontal, 10 kilonewton vertical. So I ask you to imagine if due to this load, how will be the deflected shape? So this, the deflected shape will be. So because this here is roller, roller mean you can have displacement on horizontal. And please remember you have global direction X and Y. So this is your deflected shape. From this one, you know which one is the known, which is the known is zero displacement, and the unknown we don't know yet. That's why it's unknown. This one is known. Okay. So first of all, first of all, name your nodes. So you can start from any nodes. So I take here node 1, node 2, 3, and 4. This is your nodes. Then name members. So how many members we have? Member 1, this is member 2, this is member 2, member 3, 4, 5, and 6. 6 members. Okay, next. At each node, we're gonna have X and Y displacement direction. So this is XY displacement direction. So you have to identify which one is unknown displacement, which one is known displacement due to the support. So here exactly no displacement on X and Y. However, on this roller, we're gonna have displacement on X direction, but no displacement on vertical or Y direction. So for this one, you have to remember, we have to start labeling with unknown displacement first. So for unknown, we start with the lower numbers. So we're gonna have displacement at node 1, node 2. However, for node 3, we have displacement on X. So we cannot start with node 3. So we start with node 1. So here is 1, 2, 3, 4. This one is for displacement, okay? Then between node 3 and 4, certainly node 4 don't have displacement X and Y. So we go for node 3. So 5, 6, and the last one, 7, 8. So due to support condition, 6, 7, 8 is 0. Okay, clear for this? All right. So this one you have to follow. You start with unknown first, this, then known. Then we start to draw our arrow line near to far. So near to far direction. So this is our global direction. So which point is near to our global direction? So this one is near to our point. So here is near, this is far. So near far. So this one near far. So this one is our near far direction. Do the same for member 1, near far. Member 2, this is near far. Member 5, this is near, this is far. So near far. Between 1 and 3, node 3, the location about the same. So you can take any direction. So we take from 1 to 3. So near far. So please remember, the most important one is this one. Labeling unknown displacement first. Okay, clear for that?
Yes,
okay.
clear.
Thank you. All right, then in your notes, that's why I asked you to download those notes, because my video compress everything in your notes. So if you not understand, go back to your notes. Okay, in this note indicate For unknown displacement, denoted with lower number, and known displacement with higher code number. So that one you have to remember, because we're going to do numbering for our matrix. That one is quite important. We have to differentiate between unknown and known. Hopefully that's clear. Then we go for page 39. Okay, then about near and far formula, refer back to your note figure 14.3. Alright, take this as one member. You have X and Y global direction. You know this is X, this is Y direction. This is your member. If your member tilted at any angles, you're gonna have theta Y, theta X. This is theta Y. Theta Y from Y-axis, theta X from X-axis. Okay, if take this one as one truss, so this is your global direction, Y and X. We take this member, so at this point is near, this point is far. That's why if you realize in my notes, I always put coordinate at each note, and I put global direction, X, Y. So you can take this one as 0, 0, start from here, you calculate, you find out nodes for, you find coordinate for each node. So you know which one is near, which one is far. And for that one, you learn what is lambda X, what is lambda Y. X4 minus X near divided by L, you will get lambda X. Also, you can use cos theta X. Okay, I'm not focused on this one because better you use coordinate, so less mistake for you. For this one, just for your notes, maybe if you refer some book, they are using cos theta X, cos theta Y. So if cos theta X is this theta X from X-axis to your member. For theta Y, from axis Y to that member, that angle. So that one is cos theta Y. For this case, you don't have to use coordinate. You directly use angle. So some notes, they are using this one. Maybe later, maybe you're going to further study for your master or whatever. Some of the textbook, they are using this notation. So it's originally from this formula. Alright, clear for that? The history behind X for X near divided by L, also Y for YN divided by L. That is your coordinate. And also the coordinate, you can use theta. Theta X and theta Y. Also, in some note, you can see they just use theta. That's not theta X or theta Y, just theta. That theta from X-axis. And so this one will be cos theta. Siapa tu cakap tak dengar pula?
Lutfi dia tanya, Doktor. For the near and far, we need to start from where?
Okay, near far, you take your global direction here, right? So this one coordinate is 0. So this one is near. So this one, take for this example, this member. So certainly from global direction, this is near, this is far. Okay? Nampak tak? This is your global direction. So this is near, this is far. Yeah, for all nodes. So, for example, this one, we take this member. So this one is near, this one is far. Okay, clear? Alright. So that's page 32. Yeah, all from global direction. That's why we take reference here. But when you're doing your own, it's up to you. You want to start global direction from here or from here, it's up to you. You know where is your reference point, your coordinate, your origin, 0, 0. Okay? So because in this class, I want everybody have a same direction, so I put the direction. If not, I will have, if I have 200 students, I will have 200 set of answers. Okay. All right. Clear with that? With that?
Clear,
Okay.
Doctor.
Right, great. Then we move to 39. All right, that's all. That's all. Because yesterday, last night, I went through your reply on this one because I asked you to do first. Once you done that, you get some ideas. So I try to clear it out for this exercise. So for all example in this note, using the same principle from example 1 until example 5. This example 3, example 2. So for yesterday, you learn how to assemble K. Then for today, you're going to learn this one, QKD. That's why it's important. We have to classify known and unknown. Later on, you're going to assemble this metric. From this metric, you're going to have a few equation. So later on, you have to go through next video. All right, next video very it's not for 1 hour lecture, that's for 2 hours lecture. So try to study slowly because next week you're going to study that again to continue that. Because in that you have to do simultaneous equation. Then you have to solve that simultaneous equation to get those unknown answer. Then you have to find what is displacement at each node. And also we can find what is the force inside our members. So that for next video. And also please download your note because there is formula in that. Okay. That's all for today lecture. I just to clear it out about those numbering and few important notes. All right, any question? All right. So if don't have question, about our midterm examination, that will be on 16 April Friday, as I post in Telegram. Okay, no more question. All right. For today, don't have to do reflection, but because I take your attendance from here later on, so I need you to switch on your camera. That's all for today, and I will post a link for second video, and I will write some notes what you have to do. Okay. Okay. For your information, I start with Truss because after this, you're gonna have work-based project, which is stiffness metric. And I will give some information about work-based project before or after midterm break. Okay. If no more question, that's all for today. Later on, I will. Oh, okay. I need your.
Doctor, I want to ask a question.
Huh?
I want to ask a question.
Yes.
Which chapters will be covered in our midterm test?
Stiffness metric, method, thrust, and cable.
So influence line tak masuk ah.
No, saya tak cakap kan? Cable dan stiffness matrix truss sahaja yang awak tengah belajar ni. Okay? Clear?
Clear, Doktor.
Alright. So, 42. Okay, please switch on your webcam. I'm going to print screen for your attendance for today. How many of you? 42, 41. 41. Okay. Who else yang tak buka tu? Ada ke tak ni? Kuris saya. Cam rosak. Nasib cakap. Okay, hopefully those tasks I ask you to do discussion and everything or reflection because I want to trace you, your performance. Okay, how many? 43. 1, 2, 3. All right, thank you class. Okay, Assalamualaikum and have a good day.
Waalaikumsalam. Thank you, Doktor.
Salam. Thank you, Doktor.
Thank you, Doktor.
Thank you, Doktor.
Okay, bye.
You for today.
Okay.